Well, hi, good morning. Thanks so much for joining me here in my shop. It's April 13th, Saturday. The sun is going to be out all day today. It's going to get a little warm outside, but the weather forecast for tomorrow is 15 centimeters of snow. Hopefully that's not going to happen, but oh my gosh. So, the good news on this radio is it's ready to be tested. What I've done is, yesterday on video, I replaced the big filter capacitor. Here's the replacements here. And in doing that, I cut loose three other small capacitors to get them out of the way. I've replaced those three small capacitors. So it's time to test this radio now and see if it doesn't work better. And here's the three old capacitors I took out. Interestingly enough, these two look a little different from this one. These two aren't really heavily covered in wax. This one is just gooped up in wax. It's really coated. In my understanding, this is beeswax. Maybe I got that wrong, but that's what I heard once. The other thing about this is when I unsoldered this capacitor, it turns out it was just tack soldered a little bit on the lead here, which is very unusual. So that strongly suggests one of two things. This is a replacement, or somebody previously cut it in the course of doing some kind of test on the radio and then just tack soldered it back. I don't know. Why don't we take a look at these and we'll put them on my tester. I don't know, Jim. Why don't we? Okay, let's do that. We'll start with that one. This might be in good shape. It seems to be very, very well coated with wax. Okay, so 50 volts. We'll see what happens to the eye here. Look at that. It just popped right open. 150? Well, this is like a brand new capacitor. Wow, okay, so that raises questions as to whether this is really connected even, to get that kind of response. Wow, okay, now I'm trying to read the value on here. It's buried under the dirty wax. Looks like 0.05, I think I can see 0.05 there. So let's give it a measure. 0.05 would be somewhere in here. Okay, so I guess you probably can't see that, but the eye is reacting here. Okay, you gotta ignore this machine when you're way down at the end of the scale here. Oh, there we go. Popping. So that's right near, scale we on here, 0.1. Well, that's right near 0.1. I'm pretty sure I can read 0.05 there. 0.1 is a pretty big capacitor. It's a substantial capacitor. Well, I don't know, oddly enough. So, I got a lot of conflicting readings here. It's reading a lot of capacitance and very little leakage on an old beat up capacitor. This is a bit of an oddball. I suppose it's possible the lead is separated inside, but then you wouldn't expect to find any significant capacitance. Okay, let's do the leak test first. Now this is more typical of it feels kind of dry. We'll see. Popping open great. Oh my gosh, these capacitors are fantastic. Isn't that beater of a radio? Well, let's test this one for size. This one I think I can read it here. 0.01. So it's just a slight change right in this area, but it certainly isn't popping open here. Oh, there we go. That's 0.1 again. Am I reading this properly? 0.1 to 50. Well, it can't be 0.01. So again, this machine down on the limits of the scale, not too reliable apparently. Huh. I don't know what to make of these. These are coming out really weird. Coming out with no leakage current and strange capacitance readings. So this is the 0.02. This is a 0.02. 50 volts, 250. Look at that. Oh my gosh. I wonder if these were, what's special about Aerovox? There's nothing special about these. These are typical thousands of capacitors. Okay, let's try reading this one. 0.02. Okay, we're getting the slight shadow effect again, which is not too visible in the camera there. And it reads up around 0.5. It reads up around 0.1 again. What is it about 0.1? Well, those are conflicting readings. No leakage through the capacitor, yet wonky capacitance readings. Don't think I've ever had that happen before. And now for the really fun part, we're going to start this guy up. Just good. Shake everything out of it. Oh, a little hard to start him up. He doesn't have his tubes. Tube layout chart. Here's some of them. Yeah, that's not going to help. Uh-oh. Son of a gun, I don't have a tube layout chart. Whoops. I should have made better notes when I pulled all the tubes out. Okay, I'm going to sort out which tube goes where. Try to get it at least 50% correct before we plug in the radio. And suddenly I remembered there's a tube chart on the bottom of the cabinet. It gives me a chance to kind of show you the condition of the cabinet here too. There it is. Okay, so I've been cleaning this up as much as I can. Ooh, now the top was so covered in dust you couldn't actually see that it's also got major cracks through it, all through here. This whole piece looks like it's come right out at one time, and you can see somebody has glued it back. So I'm not the first person to try to grant this guy a life, an extended life. So I think I'm going to do a fair bit of work on this cabinet in the end and paint it again, probably. There's a hole right through here. Wow, that's going to break right off. I better be careful there. So I'm thinking I'm going to remove the front panel here, right out of the back, and paint this guy up after I fix him. The way I'm planning on fixing him, I'm thinking about taking some automobile body filler and I'll sand this down, try to fill in these cracks with body filler everywhere I can. Sand her down just like a car and paint it up. So anyway, here's the tube chart. Save. Save! Lucky I remembered that. Okay. Rectifier tube goes in there. 35Z5. Okay. Output tube goes next to it. Output tube 50L6. Yep. I haven't tested these tubes yet. 12SQ7 goes here. 12SQ7. That's the detector tube. And then in between goes a 12SK7. And that's what this must be. This must be a 12SK7. It has no label on it. No label I can read. Let's just leave that one out for a minute. And the last, but actually the first is 12 SA sub. So these are all correct. Except this tube's a little funny looking. Let me just take a peek. I'm going to take a peek on the internet and see if it looks like this. It has this grill in it here. Let me take a look. Okay, so typically this is a metal tube, 12SK7 metal. I have tons of them myself. But this is also a 12SK7. It matches, the inside matches with pictures I saw on the internet. And the internet never lies. So I think we're ready to test this guy out now, once again. Yeah, I think so. Okay, and we're going to find out what it really does here. Plug it in. Okay. Switch off. I'm going to stick these knobs on just because they protrude it. Just makes it a wee bit more convenient here. What about the tuning? Tuning's going nowhere still. Can I help it? Oh, over top some kind of big bump there. Yeah. Well, I can help it from the back here if we really want to fool around. Switch is off. Now, of course, I've made lots of changes in the radio, and you know, the chances of me making a mistake in all those changes is really very good. So these dim bulbs are really important to me this time. When I turn this guy on, I'm going to watch these two lights. I got the two bulbs in here. They come on really bright. I've done something dumb. They come on bright but dim really quick. I'm in good shape. I can put new capacitors in there. There's a lot more capacity inside the filter. It's going to take longer for those to charge up. These bulbs are going to stay on bright longer. Wait a minute, that's not true. That's not true. Those filter capacitors only get working after the rectifier heats up. So we can't see an effect of additional filter capacitance until after the heater heats up. Not a problem. Okay, here we go. Here we go. And nothing should happen because I haven't got this switched on. Are we ready now for the real excitement? There it is. Good. Bulb up and down quickly. Excellent. Current voltage is 115, 116 volts. Turn some volume up. I don't hear any humming. Sounds like no volume control. Those hums. That was turning it off. Something going on with the volume. Okay, let's tune it. Oh, maybe it was just tuned into noise. Pretty quiet here. Okay, I gotta help it from behind here. I heard something. Good one. There's something there. the situation here. I'm grabbing this knob, sticking my finger on the capacitor back there, asking for an electrocution, doing stuff like that. Well, I could have sworn I heard voices come out of this thing initially there, but I'm certainly not hearing them now. So what does this tell me? What does this tell me? I think it needs an alignment, and I think the rest of those capacitors come out. I think we're going to have a great working radio. This, it tells me the speaker's good, feels good, works good. A little bit of a crack. And look who's come to visit me, of course. It's quite a hum coming out of that still. Where is he? There he is. Hello. What's with you today? Peanut, you got some stuff in your eye there. Can I get it? Can I get it? Look, wait. Here. Come on, buddy. I don't think I got it. You too. The tag team is here. No, you still got that stuff in your eye, lad. This is one of the favored cat toys in this house. These little springs. Go on. Go on. What? And leave the toy here? I'm not going to go and leave the toy here. Here. Okay. So, getting back to the radio here now. Be interesting to see if I just clear up all those capacitors, will the radio begin performing better, or will it really require an alignment in the end to bring it around? Or have I even got a bad tube in here? I wonder if I should bother testing all these tubes now. You know, we don't, I was going to say we don't know the tubes are bad, but we kind of know the capacitors are underneath. But in fact, after doing those tests on 3 of them, none of them showing up as being leaky. It's really a strange thing. Okay, what do I want to do next? I think we'll do the capacitors next, and we'll clear them out. And I think I may just do all that off camera today. We'll see. We'll see how it goes. So I still got lots of capacitors to choose from here. 1, 2, 3. These 2 molded ones. 4, 5. Well, it's only 5. It's only 5 capacitors. That's not too much. All these other ones I would leave just as they are. And as for the resistors, I'll worry about them kind of when I need to. This one can't affect, excuse me, the operation of the radio. It's just involved with this external input. This one's connecting the frame of the excuse me, I'll take that back. So this wire here, which is connecting to a lug on the frame of the capacitor, is connected to the chassis. The frame of the capacitor is then, or frame of the tuning capacitor is connected through this capacitor to the CAN, or the negative bus, I guess is what this really could be called, the negative bus. So this is draining some kind of AC signal into ground. So in other words, they've can I say this? I don't know if they, well, I'll say it, I don't know if it's true. There's a bit of a difference between the AC ground and the DC ground in this radio. Or neutral, or negative bus, I'm not sure what to call it. Okay, enough talk. Enough talk. My voice is cracking, breaking out. Let's get rid of these 2 first. Okay, we're ready for another test. Now, I don't expect it actually to work any different with that little change. That's why I'm going to test it. Rather than rely on my expectations. Volume down. Also, you know, as you change parts, it makes sense to test the radio. Oh, let's test the parts first. Let's test these parts first. Yeah, let's do that. First this guy, 0.02. Molded. 50 volts. Can he take it? Oh, he sure can. 150. Wow. It's just something wrong with my machine. Am I doing something wrong with this capacitor? That checker? How can it check every capacitor high like that? Quickly, I need an old beater of a capacitor. Maybe the next one. Well, let's measure this one too. Can't believe it's coming out good. 0.02 is going to be in here somewhere. Okay, right at the bottom there. So right at the bottom is 0.1. It's supposed to be 0.02. What's going wrong with my box? Oh, maybe that's been causing trouble all this time. Hey, didn't do anything. So I left this on electrolytic. Didn't make much difference. Maybe it's really only on the leak. So watch this now. Everything's going to turn out leaky. That's what's going to happen here now. For sure. That's more normal. That's okay. So I had this set wrong. You know what? I got to put some kind of a warning or something on this knob here. Okay, so 250 volts. It's still opening. Not very well though. Okay, so all my previous tests were bogus here. Suspicious of my test, but not suspicious enough to get them right. Until now. So once again, if the test results are close to what you expect, you will accept bad test results. Especially if what you expect is totally wrong too, then you're really in trouble. 0.02, 50. 250. 250, it doesn't open at all. I'd rather find out these are bad, you know, than find out I'm replacing good capacitors. Now, these miracle workers, they aren't going to be so miraculous anymore. 50 volts. Doesn't open. That's a little different than having it set here and seeing that. That's the whole difference. It's a dud. Okay, so we've gone from surprisingly good, but remember the capacitance test wouldn't work right, and that also added to my suspicions, because when the capacitance measurement test does wonky things, it usually means it's because there's too much leakage through the capacitor. The instrument can't function properly. 50 volts, these are shot. Okay, so these have gone from, oh, these are really good, to, these are shot. These are totally shot. Okay, here we go. 50 volts again. Trying so hard. This thing can't even take 50 volts without producing an eye-closing leakage. Okay. I feel better now. And now, you know what? I even feel that maybe we're going to see a difference in performance here. Let's find out. Volume down. So I just switched it on, didn't I? Not plugged in. Good for you. Good for you, Kim. Okay, ready on test number 2. Dim lights behave perfectly. Volume up right away. We'll listen to it. Took a long time. So I can hear a distinct hum in there, like 120. Still have volume behavior problems here. There's that hum. Listen to that. It's not so much from the, well, it's not affected by the volume. It's almost like the power supply still. Okay, don't worry about that. Let's tune the radio. Play me something. Okay, I'm going to rotate the antenna 90 degrees here. I can't see the dial. How about the other 90 degrees? Okay, the other 90 degrees. There's a voice there. That's probably 680. 680 is a strong station, but it has heavy interference in my house, right on the edge of 680. 640 is a better catch. That would be, if that was 680, this should be 640 right here. No. So performance still crap on the radio. The volume right. So you heard, when I was banging it, you could hear the sound of the radio changing a bit. It was probably retuning. It was probably the tuning capacitor drifting as I'm banging on the radio. There seems to be some hit and miss performance on this thing. Performance? I shouldn't even use the word performance with it yet. All it's doing is pretty much letting us know what kind of noises are here in my shop. So, no performance yet. Now, we can expect reasonably good performance from this radio because it's got a nice antenna here. Still hooked up. There's a funny, yeah, I noticed earlier the rather odd arrangement here where a unterminaled wire is just soldered to the antenna. And what else? This just looking at how these are certainly coated wires here. They look bare, but I'm sure they're actually coated. The coating isn't going to be all that great, and look what's going on right in here. It's practically shorted. I don't think it was shorted though. But and then there's this red. See the little red wire there? So where's that supposed to go? So somebody's done something here, and it wasn't me. Let's take a little closer look at this just for a second. Maybe we can sort a little bit out. Oh my gosh. I'm saying oh my gosh because I think part of the schematic here, let me turn it around. I think part of the schematic is missing. So T1 is part of this, I'm sure. There should be a T2. Total resistance. I don't know. There's a piece of the photocopy missing. It looks like it might be missing here. Just you can see like a little bit of an edge missing there. So maybe there's more out here. I don't think this is going to help us much. This shows from the antenna 2 wires making it into the radio. So I have 1 wire here. The other wire coming here. What's this terminal? This terminal doesn't seem to go anywhere. Yeah, what's going on there? What is going on there? Let's take a bit of a closer look. I think I might have to solve this before we go any further. This could be why the radio's not performing well at all. Just bear with me while I correct the focus on the camera. Just takes a minute here. I have to call up the camera dialog box to do that. Big ball of dust in there. Let's get the ball of dust out. Guess I missed it when I was vacuuming. Okay, so now we can see clearly something is amiss here. So what I see is this terminal. Let me change the camera angle on this a little bit here. I think I can do it a little more justice if I just do it like this. So this terminal is grounded right onto the chassis. This terminal is going nowhere. So there's a wire connected to it, this wire, from the loop antenna to this terminal, and then there's a red wire that's been cut. Something's wrong here for sure. Look, you know, there's just a chance that really what this is a way to hook up an external antenna, a long wire antenna. And this red wire, and perhaps one off of here too, might have been hanging out the back of the radio. I doubt this very much. Yeah. I doubt it, but what else would that little piece of red wire be doing there? Why would somebody cut it? If it was going somewhere, you'd think they would cut it and reconnect it if they're going to cut it. So perhaps again, it was laying out the back of the radio, meant to be a place to hook up an antenna, and somebody cut it back. So that would mean usually the way these coil antennas work, usually loop antennas here. Let's get on the other camera. I think it's a little easier. They usually have 2 windings, and one winding is connected to the radio. It's like the secondary of a transformer, and the other winding is like the primary of a transformer, and that winding is hooked up to nothing except usually a capacitor, usually an adjustable capacitor that can be used to tune that coil. So when you tune the coil that's connected to nothing, it resonates at the frequency you want. It develops quite a lot of going on here, and some of that gets in the other wire, the other coil, shorter, looped a few times, and that's the signal that's shot into the radio. So quite often on these you'll find a trimmer capacitor. I don't see one. So in effect, so this also, the part of the coil that's connected to the radio represents part of a tuned circuit working against the capacitor here, the tuning capacitor. So what I'm trying to do is I'm trying to clear my head enough that I can determine if there's something really out of whack here, or if this is the way it is. What's made me suspicious is this weird connection here. I'll look a little closer at that. So this is just not the way they normally do things in the world of radio manufacture. It's not a red wire. Wait a minute. Wait one cotton picking minute. So I said a minute ago, perhaps there was a red wire and a black wire hanging out the back of this radio. And then I said, where'd the black wire go? Then right after that I started talking about this black wire, which appears to be in a weird place. Okay, so here's my thinking. Somebody cut the red wire away, took the black wire, fed it up there, through the holes there, and soldered it to these wires, which they removed one from this terminal. And why did they do this? Because they were fooling around, and this arrangement seemed to make the radio work better. Consequently, this is all wrong. Potentially all wrong under that theory. But this does not look resoldered. And the way the wire's been put through here on the back of the board, it looks like that's an intentional design rather than an opportunity. So in other words, that's how I'm mumbling about, this isn't fixed in place, but it is. If you run it, the wire through those holes, this is kind of fixed now. If I look at this, if this schmozzle was done by somebody, they did it a long time ago. I don't see any evidence that this is new, but then how can you really tell? So what about which wire's which? So you see, when I look at this, I see one wire here. You don't see it because you haven't got the camera right. Let's get the camera right here, Jim. Okay, so I see, it's very hard to see. Okay, so I see these two wires here. These are easy to see. There's two more. There's one here going to this wire and one coming up from down here going to this wire. So what would that be? If this makes sense, then this is two wires being grounded to the chassis coming from two coils, one of which should be isolated away from the radio entirely. It doesn't make sense, does it? So let's look at the schematic again. See if we can extract a little more out of this. Wow. Well, again, there's one wire coming from the coil attached to the chassis. The other wire is on its way into the radio. It's attaching to the tuning capacitor. And that's just what we actually see there. One wire's to the tuning capacitor. And there is another wire going to the ground here. Now there's another wire going to ground, but we don't see it in here at all. Well, I'm going to have to guess there's a lot more out here we're missing and without it. Or is that just supposed to be the wire hanging out the back of the radio? It's only one wire. One red wire hanging out the back of the radio. Yeah, I'd like to just say, oh, it's okay and carry on, but if somebody has monkeyed this up, this radio is never going to work right. And the radio is exhibiting exactly the kind of symptoms it has when an antenna like this has been monkeyed up. The symptoms being that the radio receives noise, but it can't tune in a signal with any kind of strength at all. Well, maybe the best thing to do is leave this alone for now. We've certainly made quite the observation about it, and carry on with the rest of the radio. Maybe in the end the radio is going to work 100%, and I can just forget about this thing and assume it's all correct. On the other hand, maybe when I get all done, there'll still be some deficit in the radio, and then I can be more suspicious about the antenna here, along with some other testing I can do. So I think the bottom line here is maybe the antenna is messed up, maybe not. I should carry on replacing capacitors. So on that note, let's flip it over and pick the next round, which might be all of them. What is there left in here now? 3? I think there's only 3 left in here. Let's see. 1, 2, 3. Yeah, just 3. Just 3. 3. That's easy. And a big guy here doing that looks like signal grounding on the frame of the tuning capacitor. And we have this guy who is involved with I think it's the 6SA7 here, I think. So this is the very front end. And then we have this one. I don't know what he's doing. Oh, this is just part. Whoops. Don't do that. This one back here is just part of the phono plug. So there's really only 2 here that can have any kind of effect on the operation of the radio. Wow, I put all my eggs in those. All my eggs are with those 2 capacitors. That's my statement of the day. Okay, let's go. So I'm looking for C9. Well, that looks like C9 right there. It's attached to, I guess we could say it's attached to R2. Okay, R2 is 2200. So that would be red. R2. Okay, in the radio. And we're looking for a resistor right off of over here. Well, there's a 2.2. That's not right. It's not on the right terminal. Where did I get this capacitor from? Down here. And then it was over to somewhere. It was here. And that's potentially connected to all kinds of stuff in the radio here. Well, I don't see that resistor. It's not happening. That didn't happen. 0.03. I don't get it. 0.03. Sorry about the focus there. Oh, that may not have gone very well. Well, let's try giving this guy a test here. Leakage first. Whatever it is, it's shot. So I'm not going to be. I was hoping to read its capacitance on here. Well, let's try it. I can't believe it would ever work. What's that? What are you saying there? 0.03 is going to be on this scale. So you get a little wiggly thing. Again, it doesn't show up on the camera. It's right around 0.05. 0.03. Well, 0.03 would be right here. And look at this closely. It says 0.03 to me. Now, why is this? This is bigger. Yikes, this is 0.025. Well, that's okay. I put a 0.02 in. It's not going to matter. I don't think the 5 is going to matter. I don't know. It seems like it's too big a capacitor to be a 0.03. All indications are it is a 0.03. Okay. I gotta make a decision here. How can I make a decision on this? Well, let's see. What its range would be 0.03 to a big one like this would be a 0.1. That's a huge difference. If I'm guessing this is a 0.1. In the parts list, there is no. What is that? I already looked at this. Let's try it again. The biggest paper capacitor. .05. There's the 0.025 and 0.03. C9, 0.03. And then we look here where we think it might be. Let me see what looks like a C9 hooked up to an R2, but you know what? It's hooked up to a wire that hooks up to a lot of stuff. So, you know, finding R2 is a major. Well, 0.03. Okay, let's do it. Let's see if I've got such a thing. A 0.03 is kind of a weird size here. What makes you say it's a weird size? It's an odd number. It's not weird, it's certainly odd. So that's about 3,000 picofarads, which is 0.003. 0.003, wait a minute, that's not right. 3,000 picofarads. That's 0.003. Where did I get that from? No, I got it out of the tray that says 0.003. This is why I do these tests. Let's try 0.03. That might be a little better. So that's 30 nanofarads or 0.03. That's it. There we are. So if I'm putting in the wrong size, I'm pretty sure of it. Anyway. See if I can remember anything at all about where it came from. This guy's easy. 0.05. So this actually got more capacitance than that big one I just did, 0.03. Which Peanut, you sound like you've become an old man. Peanut's 8 years old, so he's a middle-aged cat. Oh, sorry, I shouldn't have said that, should I? It's true though, you're middle-aged. .05. 0.05. Amazing how quickly you can forget where things come from. There. There we are. Okay, so I'm going to leave this capacitor over here in for now because I'm sure it can't really have any effect on the radio. I'll change it later. Let's test this one more time here. See what we get. There we go. Another try. Switch is off. I was doing extensive tube testing last week, testing 6 SN7 tubes. I discovered that some of them require a long time to heat up, as opposed to others that seem to heat up much quicker. Long time being 15 seconds, 20 seconds. Okay, what can we tune in on here? Well, the answer appears to be absolutely nothing. That's let's try the 90-degree trick here. The antenna may be turned, like a lot of these stations I'm trying to pick up are all coming from the same direction. So if I got this turned the wrong way, nada. Wow, that's a pretty big 0. That's a little bit surprising. So next step on this radio is to do the alignment. And if that doesn't bring the radio to life, then it's tubes after that. And if that doesn't bring the radio back to life, I may have wasted a lot of time. So something's going to bring this guy back to life though. So thanks for watching, and onward.